We discussed the force vectors and vector operations in the last couple of videos, and from this video onwards we are going to deal with the most interesting and important stuff of engineering mechanics, forces and moments. So what you're going to study in this video is resolving the force into two components, finding the resultants of a force system, a coplanar force system acting in a plane, and finding the net resultant force in a force system. So in the figure shown, you have got a force of 40 kilonewton acting at an angle 30 degree with the x-axis. So you have your axis system x and y and a force of 40 kilonewton. To resolve the force into two components, I just shown this simply here. What you need to do is create a lower triangle or an upper triangle around the force. The condition is you need to create the base and perpendicular of a triangle, or you need to create a right triangle. Then you can resolve the force into two components. One will be parallel to the x-axis and the other parallel to the y-axis. So the lines numbered 2 are the ones parallel to the y-axis, and those lines numbered 1 are the ones parallel to the x-axis. You don't have to create both of these. You can either create the one and below or the one above the force. So in this figure, the x component of the force is 1, that is x component of force F1, F1x is F1 cos 30, which is 40 into cos 30, 34.64 kilonewton, and the y component shown as 2 is F1 sin 30, that is 20 kilonewton. You can check it by yourself. So it is as simple as that. Just take the cos component of the angle, multiply with the force, and you will get the x component of the force, and take the sine of the angle, multiply with the force, you will get the y component of the force. The resultant of these two forces will be 40 kilonewton acting at 30 degree. So that is the concept. You resolve the force into two components so that the resultant force of those two components will be the original force. You can either create a lower triangle or an upper triangle. In fact, you are creating a parallelogram, or you are repeating the parallelogram low here or the triangular low here. You create a triangle, resolve the force into two. Let's see if we can apply this theorem into a more complex system of forces. Don't get confused seeing this figure. I'm going to explain it to the very detail. In the figure, you have got your x-axis and your y-axis, and a force acting at 30 degree with the x-axis of 40 kilonewton, and a second force acting at 120 degree with the x-axis. The force is 15 kilonewton, and a third force of 20 kilonewton acting at an angle 240 degree with the x-axis. We have already resolved the first force, the 40 kilonewton, into two components, the x component and the y component. So you've got 34.64 along the x-axis and 20 kilonewton along the y-axis. So what we are going to do now is resolving the other two forces. So let's consider the second force of 15 kilonewton acting at an angle 120 degree with the x-axis. Again, that's been shown as a parallelogram. Here it's a square or a rectangle. You can either create a lower triangle or an upper triangle. So just find the cos of the angle, that is 120, multiply that with the force, you will get the horizontal component or the x component, that is F2 cos 120, that is minus 7.5 kilonewton. And because this is a minus sign, there is a negative sign, which implies the force is acting along the negative x direction, or that is from the origin the force is acting towards this direction. If that was a positive, then it must have been in the positive direction of the x-axis. Now to find the vertical component or the y component, simply find the sine component, sine of this angle, multiply that with the force. So you have F2 sine 120, 12.99 kilonewton. Now going to the third force, you have 20 kilonewton acting at an angle 240 degree with the x-axis. So that's shown here again, 20 kilonewton acting at an angle 240 degree with x-axis. What you need is find the sine and cos of 240, multiply that with the force, you will get the two components. So cos 240 into F3 will give you the x direction component or the component along x-axis, and sine 240 into the force will give you the vertical component or the component along y-axis. So minus 10 and minus 17.32. Now to find the net forces along x and y-axis, what you need to do is you need to find the sum of all the forces along the x-axis and all the forces along the y-axis. So that will give you the resultant forces in x direction and y direction. So the net force in x direction is Fx is F1x plus F2x plus F3x. So we have already calculated F1x is 34.64, F2x is minus 7.5 and F3x is minus 10. So the net force along x-axis is 34.64 minus 7.5 minus 10, that is 17.14 kilonewton. And for the net forces in y direction, you have Fy is equal to F1y plus F2y plus F3y. So we have already calculated the y component of first force as 20 kilonewton, and for the second force 12.99 kilonewton, and for the third force minus 17.32 kilonewton. So the net force is 20 plus 12.99 minus 17.32, that is 15.67 kilonewton. You can check it out by yourself. Now the resultant force is, you have got a resultant force in x direction and a resultant force in y direction. So if you draw the forces as a vectors and then find the resultant of these forces, then what you're going to get is the net resultant force of this entire force system. So that's what we shown here. You have got an x component of 17.14 and a y component of 15.67. So you can draw the vector and find the resultant. That is graphical method, and if you want to do it analytically, and then you can also find the angle simply by measuring the angle between the force and the x-axis. You can find the direction of the force as well. So you have the base and perpendicular of a right triangle, and you need to find the hypotenuse. So the resultant force will be square root of, if you consider this as a right triangle, this side will be square root of x square plus y square, where you have x 17.14 and y 15.67. So the resultant force is 17.14 square plus 15.67 square and the square roots. That gives you 23.22 kilonewton. And to find the theta or the angle or the direction of the resultant force, you have tan theta is y by x, that is y divided by x. You know it's 15.67 and 17.14 for y and x. That give you 0.914, and the theta is tan inverse of 0.914, that is tan inverse 0.914 is 42.43. So the angle or the direction of the resultant force is 42.43 and the magnitude is 23.22 kilonewton. You can try this example by yourself to make it thorough.